Welcome back, everybody. So we're going to continue our lesson on the multiple angles today. Yesterday we looked at problems where the b value was an integer value of 2 or 3 or 4, and that integer value indicates rotations around the circle or cycles within a interval from 0 to 2 pi, which is why you saw more solutions. Okay, so today we want to look at some more examples and maybe even give you some b values that are not integer values, but are fractions. So let's take a look at our first example. Okay, we're solving over the interval from 0 to 2 pi. It looks very similar to what we did yesterday, so this should be review, but just kind of reinforce what we talked about. All right, what this 2 means here is that we're going to go around the unit circle twice, or that there are 2 cycles of this curve between 0 and 2 pi. And if you think about that, the interval or the period of this graph would be pi. So you would create one curve and then you would create the second curve. Now this 2 means that instead of having 2 solutions, we're actually going to have 4 solutions. So this tells you how many solutions you're going to have, or indicates what you can do to figure out how many solutions you're going to have. So I'm going to have twice as many solutions as I normally would. So in this example, looks like yesterday, we're going to go ahead and we're going to divide both sides by 3, and we're going to get our sine 2 theta is equal to negative 1/3. And we're going to make our substitution. So I'm going to use alpha. You can certainly use a different variable, whatever works for you, but alpha is equal to 2 theta. And I'm going to solve for alpha. So I need to take the inverse. So alpha is equal to the inverse sine of negative 1/3. Now negative 1/3 is not a value that I have on my circle that I know. So I'm going to have to go to my calculator. So when I put this into my calculator, because sine is negative, it's going to give me a negative angle because your calculator solves in the interval from negative pi over 2 to pi over 2. So here's my angle. It's negative 0.3398. To round that correctly, you actually need to bounce this up 2. So it ends up being negative 0.334. Oh, sorry, 340. So my reference angle is positive 0.340. So we're going to bounce that up. Where is sine negative? Well, sine is going to be negative in quadrants 3 and 4. So when I have my reference angle, I need to remember I'm going to add that to pi to get my quadrant 3 angle and subtract it from 2 pi to get my quadrant 4 angle. So my two angles are 3.482 and 5.943. Now, because we're going around a second time, I'm going to take these two angles and I'm going to add 2 pi to each of them. That would be my second rotation. So here are my 4 angles, and I'm going to replace my alpha with my 2 theta, and I'm going to solve for theta. So we're going to divide everything by 2, and then I'm going to get my 4 solutions stated below. Now notice that when you should always be checking to make sure that your angles fall into the interval from 0 to 2 pi. And since 2 pi is a decimal, is approximately 6.28, all 4 of these solutions will work. Okay, it's just important that you are always making sure that your answers make sense. So the next problem, we haven't done one like this, but notice our b value is 1/2. So if 2 means we're going around the circle twice, and 3 means we're going around the circle 3 times, then 1/2 means we're going around the circle only 1/2 of the time. So that means we're only using quadrants 1 and 2. Okay, so that's what we need to think about when this becomes a fraction. We need to think about, like, are we really using the whole circle, or are there going to be things that are excluded? We'll come back to that, like, when we start solving. So I'm just going to go ahead and solve this like I would normally. I'm going to move the 1 over and I'm divided by 2. Okay, because it's squared, I'm going to square root both sides. Don't forget your plus or minus. And I'm going to get the cosine of 1/2 theta is equal to plus or minus root 2 over 2. So now I'm going to make my substitution. Since alpha is equal to 1/2 theta, I'm going to say cosine alpha is root 2 over 2, and cosine alpha is negative root 2 over 2. So the angles I'd normally get for cosine of root 2 over 2 and cosine of negative root 2 over 2 are pi over 4 and 7 pi over 4, and 3 pi over 4 and 5 pi over 4. Think about where 7 pi over 4 is. Think about where 5 pi over 4 is. Now, if I just kind of go through the steps that we've been working through, which is fine, I'm going to go ahead and I'm going to replace my alpha with my 1/2 theta. So I'm going to set each of those angles equal to 1/2 theta, and I'm going to get these angles. Now, think about what we said before. We were only using half the circle, so we were only using quadrant 1 and quadrant 2. This angle here is a quadrant 4 angle. This angle here is a quadrant 5 angle. The numerator's 5, quadrant 3 angle. So when I solve, it puts them out of the interval from 0 to 2 pi. Okay, so the 1/2 is telling us we're only using quadrants 1 and 2, which is why these two solutions are too big. Okay, so we want to make sure that our answers make sense. All right, our next example is going to be a tangent. We haven't talked about tangent yet. Again, tangent's the same idea, okay, but we just have to remember, tangent is positive in quadrants 1 and 3 and then negative in quadrants 2 and 4. Okay, so this 3 will indicate that we're going to go around the circle 3 times. Well, normally we would have 2 solutions, so that means now we're going to have 6 solutions. So I'm going to go ahead and I'm going to replace my 3 theta with alpha. And I'm going to solve. So tangent alpha is equal to -1. So the inverse of tangent of -1 should be 3 pi over 4 and 7 pi over 4. Okay, so this is my quadrant 2 angle. That's my quadrant 4 angle. Now, I'm going to add pi to to the 3 pi over 4, because that would be the period of a normal tangent graph. Now, I could add 2 pi to this, and I could add 2 pi to this, and that works just fine. But remember, like when we wrote the equations last week, and we would say, what is it for all solutions? Well, for sine and cosine, we would take our angle and we'd say plus 2 pi k. But for tangent, we could take our angles and say plus 2 pi k, or because of the where it's positive and where it's negative, we could just say pi k, which is why I'm just adding pi instead of 2 pi. So if I take 3 pi over 4 and I add pi, it gives me 7 pi over 4, which was my other angle. And I'm going to add pi again. I'm going to add pi again. I'm going to add pi again, and add pi one more time. Okay, so adding pi 5 times to the 3 pi over 4 gives me my 6 solutions. Okay, so here are my 6 angles. Remember, that's not what theta is, that's what alpha is. So we need to set each of those angles equal to 3 theta. So I'm going to divide each angle by 3, or multiply by 1/3. And here would be my 6 angles. So I have pi over 4, 7 pi over 12, 11 pi over 12, 5 pi over 4, 19 pi over 12, and then 23 pi over 12. Okay, again, just checking, does this fall into this interval? Yes, all of those fall into the interval. So always make sure that you're checking to make sure things make sense. And I think on the next example, you'll maybe have a better understanding of why I keep saying that. Okay, last example that we're going to do together is cosine of 3/4 theta equals 0.7. So when we think about that, we're talking about 3/4 of the circle, right? Okay, so I'm not talking about the whole circle, I'm not talking about half the circle, we're talking about 3/4 of the circle. So let's go ahead and start. We're going to say alpha is equal to 3/4 theta. And because 0.7 is not a value that I know from my circle, I'm going to go ahead and use my calculator. So I end up with 0.795. Okay, that's what the calculator gave me. And then my quadrant 4 angle, which would be 2 pi minus my reference angle, is 5.488. Okay, remember, what does the 3/4 mean? The 3/4 means that we're only using 3/4 of the circle, which means this quadrant 4 angle probably not going to give me an answer. Okay, so we have to think about those things, but let's just check. So if I continue to do the things that I've been doing, and I set my angle equal to 3/4 theta, I'm going to multiply both sides by 4/3, and I'm going to get theta to be 1.061. Great. Remember, the 0.795 was our quadrant 1 angle. If I take this angle, the 5.488, multiply both sides by 4/3, it gives me 7.317. Well, this is bigger than 2 pi, which is why down here I was kind of saying, we know this is quadrant 4, but we also know we're only using 3/4 of the circle. So it makes sense that this angle right here didn't work. Okay, so you can actually think through these and understand that, you know what, that's not going to work. It's too big. It's not 3/4 or within the 3/4 of my circle. It's in quadrant 4. Now, if this was a negative 0.7, guess what? You would have been in quadrants 2 and 3, and you would have had 2 solutions, and that would have been okay. So you really need to think about what the 3/4 is meaning, and you need to think about what that means in context of where the angles are falling. Okay, so my last question that I want to pose to you is this. Okay, if you were given the equation sine 1/2 theta equals negative 0.4, how many solutions would you expect and why? So think about that, and hopefully when we see you on Thursday, we'll be able to talk through that answer. Have a fabulous day, and we will see you soon.